In this lesson, we're going to look at rational exponents. So I posted a video of the exponential laws or laws of exponents in the previous lesson. So just a review of the exponent laws. So here we have 0, anything to the power of 0 equals 1. We looked at negative exponents. We'll look at a bit of that today. Multiplication, we add the powers. Division, we subtract the powers. We have a power to a power, and then the power to a power can be applied to multiplication or division. So those are sort of the laws that you have learned in grade 9 and grade 10. Just a reminder of negative exponents. I'm not sure if this was covered in the last one. So a negative exponent, let's get a pen here. A negative exponent really defines position. Doesn't make it a negative number. It sort of tells you the location of the base. So for example, let's just go down here for a minute. If I write 5 to the negative 2, well, let's look at the law. Let's start again. So if I had 5 to the power 3 divided by 5 to the power 5, that means that I have 3 5s in the numerator divided by 5 5s in the denominator. That's what that means. So if I reduced, 5 divided by 5 is 1, 5 divided by 5 is 1, 5 divided by 5 is 1. So what is our result? 1 in the numerator. We have 2 5s left in the denominator. If I did my shortcut of division, where we subtract, 3 minus 5 is negative 2. So you can see that the negative 2 tells me that I have 2 5s left, but they are not in the top, they are in the bottom. So it defines where they are, the position of the base. So in this example, you want to write the following without using negative exponents. That's generally what they'll ask you to do with exponential equations or expressions. They don't want any negative exponents at the end. So here I see a 4 with a negative exponent. That means it's going to move to the bottom to make it positive. There's already a 9 there. If I move the 4 to negative 1, I just have 1 left. The 9 does not move because it does not have a negative exponent. So we're not going to move anything that does not have a negative exponent. In B, the 6 has a negative exponent, the 5 doesn't. So the 5 is going to stay where it is. The 6 to the negative 2 is going to come back to the top, and that negative 2 becomes positive 2. 3 to the power 6 is 36, and what does that give me? 180? 180. In this question, the 2 has a negative exponent, the 3 does not, so the 3 stays where it is. The 2 is going to come to the bottom to make it positive. If there's nothing left, we'll just put a 1. So that's going to be 1 over 3 to the 16, so 1 over 48. Let's skip down to E. So this has a negative exponent and this, so they're both going to move. The 9 is going to move to the bottom to make the negative 1 positive 1. The 3 is going to move to the top to make the negative 4 positive 4. That leaves me with 81 over 9, which is 9. Okay, so if it has a negative exponent, you want to move it to make it a positive exponent. If it does not have a negative exponent, do not touch it. Okay, what is a rational exponent? Well, as you remember previously, a rational number is anything in the form a over b, right? A fraction. So it's another way of writing a fraction. And b cannot be equal to 0 because that's the denominator. We can't divide by 0. So what does this fraction exponent mean? What if I have 16 to the power 3 over 4? The bottom number in the fraction tells you what kind of root. So these are roots. Anything with a rational expression is going to be a root. The bottom number tells you the kind of root, and the top number is the power or the exponent. So if I have 16, 16 is the base. The number on the bottom is the root. So that tells me it's the 4th root of 16. The number on the top is the exponent, so that tells me it's to the power 3. So I always like to do the root first. You can do the exponent first if you want, but then you're going to get a big number. So I'd rather do the root first and then do the power after. So the fourth root of 16 is 2. You will have a root button on your calculator. It's usually near the exponent button, so it usually looks like this. And you can tell it what kind of root to put in. The fourth root of 16 is 2 because 16 equals 2 times 2 times 2 times 2. So 16 consists of 4 2's. So the fourth root means you need 4 numbers the same to equal one whole number. So the fourth root of 16 is 2. And then we'll do that to the power of 3, and that's 8. In this question, 27 is the base. The number on the bottom is the root, so that's 3. And then the power, or the exponent, is 2. So the third root of 27 is 3. Again, you can put it in your calculator if you like, but the third root of 27 is 3 because 27 is 3 times 3 times 3. It consists of 3 3's. The third root means you have 3 numbers the same to equal one whole number. So the third root of 27 is 3, and then I'm going to square that, which gives me 9. You might have a negative exponent. So remember, all a negative exponent means is that it defines your position. So in order to make that negative 1/3 positive 1/3, we're going to move that whole base to the bottom. Then we can change it back to a root. So 8 is the base. The number on the bottom is 3. So it's the third root of 8, which is 2, to the power 1 is just 2. In this example, the last two examples I put here because one has brackets and one does not. If it does not have brackets, it's not included. So when I do the 25, only the 25 is going inside the root, not the negative. The 2 means a square root, and the 5 is the power. So if that was negative 25, I could not square root, because you can't square root a negative number. Now, since there's no brackets, it's separate. So I'm going to do the square root of 25 to the power 5. And then the answer will be negative because the negative was separate. In the next example, there's brackets around the negative 64. So that means the negative goes inside the root with the 64. The number on the bottom is 3, so it's the third root. So we can cube root an odd number. If you think of 64, it consists of 3 4's. So they could be negative because we have an odd number, right? A negative times a negative is a positive, times a negative is a negative. So that's okay to have an odd root of a negative number. So the third root of negative 64 is negative 4, and then we'd square that. Keep your brackets, so that means negative 4 times negative 4 is positive 16.